Hello YouTubers, this is Shreyas Joshi. This is my second video on C++. Today I'm going to talk about uniform initialization. Yesterday I was reading a book by the C++ creator called Biana Stroustrup. So Biana Stroustrup says that in modern C++ they have introduced uniform initialization to fix some of the implicit type conversion problems in C++. So as we know that C++ parental language is actually C, or you can say that it's probably it will be wrong to say parental language, but it's pretty much a lot of things have been taken from C into C++. So uh, let's jump into the code and see what I'm talking about and what modern C can do it to fix this problem, what I'm talking about using uniform initialization. So let's create a file called uniform init, or maybe give some, let's say give main uni.cpp. Okay, let's give a header file as we give it iostream class to use couts, and let's use the namespace std so that we don't have to use fully qualified name all the time. Now let's give int main. This is the function parameters, main one, which is argument counts and total pointer of argument values. So pass that. Now I'm talking about this. Let's say you have an integer c, integer integral type, and now you're assigning. So let's not call assigning, it's called initialization. It's called declaring and initialization because I am giving, because it's called declaring and initialization. So in C++, you have two concepts. You call it initialization and you call assignment. So this is called initialization. Why? Because you can see you have declared a type called integer, integral type, and assigning the value 2.342 there. So this is called declaring and initialization. Whereas if I do integral equals to 3, this is called assignment. So it's very important to know that. I think C++ distinguish a lot initialization and assignment. So in this topic, I'm talking about uniform initialization. So basically, I'm talking about the first point, which is declaring and initializing. So let's see what happens. Let's comment this line. Let's comment out the line number 8. And if I go to line 8, and I comment this out, and if I go and print the integral value, integral val equals to integral find that C++ has done implicit conversion here on line number 7. It has done implicit conversion, and basically the data is lost. Basically, data is lost. You are basically narrowing down. You're converting a floating point to integral. So you have lost all narrowing down, and you have lost the decision point. The bad part about C++ compiler C is that it will not even throw any compilation warnings or error. So with this, you can see that it just compiles. Even if I use my new C++ compiler, C++ 17, and mean _uni and -o to get the output uni.out, and you see that it still shows no warning. So now in the book, he says that this problem has been fixed. Basically, the initialization problem has been fixed using uniform initialization. So let's see what he's talking about. So he says that instead of integral, like equal using equal sign. So basically equal sign, this operator can be used for assignment, for initialization, as well as assignment. So he says that for initialization, don't use equal operator. In fact, use the uniform initialization, which we'll see. So uni integral, and he says pass like this. So if I do this, this is uniform initialization syntax. Now how it helps. Now let's say if I have another integral, and if I assign say 5.324, this will throw error because it will say that you're trying to narrow down a double value to an integral. We'll see that. And if I try to put my uni integral value is uni integral, this should work because we are giving the 5 value here, whereas here we'll get the wrong value. Another uni integral is another uni integral, and we get an error here. So if I compile it, I get an error. Say I get narrowing conversion of 532 blah 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 double to n. This is an error. This is exactly what I was talking about. That with the uniform initialization, you can avoid such errors. So if I remove this to back to integer, it will. So if I try to print, if I run this, execute this program, I see integral value 2, uni integral value 5, and now the uni integral 54. So this is all about initialization, and this is how it works. However, still feel this problem just fixes part of it. Still, you can do a blunder by using assignment operator rather than initialization operator. So if you use assignment operator, basically assign a floating point to an integer, throw an error. So this only fixes the initialization part. Thank you for watching.